Hi, Mark Granis here with lecture 5.4, supposition again and distribution. This corresponds with section 5.4 of our text, The Reasonable Person. We have two topics today, but they are not by any means of equal importance. One of them, supposition, is something we've covered a little bit before, and we're just going to take a quick second look at supposition just to touch up one other point about it that really wouldn't have been obvious the first time we covered this back in chapter 2. So we're going to take a second look at supposition, but then we're going to move on pretty quickly because the second topic today of distribution is really important. It'll be very important for the next few chapters that we cover. So we'll talk about distribution in general, and then we'll talk about the distribution of subject terms separately from the predicates, and then we'll consider the distribution of the predicate terms. We'll end with an enhanced matrix of the four basic categorical propositions, showing how distribution fits into that. So let's get started. First, let's just go back to what we learned about supposition in chapter 2. We learned there that supposition is the mode of existence toward which a term or other signifier points. And we talked about three different types, which you can see right here. There's logical supposition, which is the normal case. That's what we usually have, where a term that we use refers to a universal, and it refers to the concept itself, right? The logical concept, the thought. So when we say cats are not the only animals that purr, we're talking about the universal cats as a logical concept. Or we could say cats is a four-letter word, and then we're not talking about a thought at all. We're talking about the word. Cats is referring to itself as a term. We call that verbal supposition. Or it could have real supposition, where I say, I heard two cats fighting last night. There I'm not talking about the concept, and I'm not talking about the term. I'm talking about a couple of representatives, a part of the extension of cats. So cats in these cases supposits differently in each example. But here's the simple point that I want to make today. We only know that by reading the entire proposition. And that's not a point that I wanted to emphasize back in chapter 2 because you didn't really know what propositions were. But imagine now if I tried to make this example by saying, well, there's logical supposition like cats, and then there's verbal supposition like cats, and then there's real supposition like cats. Well, that would be stupid, right? There's no difference among those things. The only difference, the only way that we know that there's different supposition in these cases is from reading the entire proposition. So even though supposition is a property of terms, it is a property of terms that we assign by interpretation. And the somewhat more subtle but more useful point is that as a practical matter, what that means is that supposition is a tool that we can use to make sense of other people's words. It's not something that we just make up in order to have a fancy doctrine. You may go your entire life, you probably will go your entire life without starting at the end of the example that I started at as a logic teacher. You'll probably never think, I wonder how I can use something with verbal supposition. But there will be times when you make sense of someone else's words by considering that possibility. So that's really what supposition is all about, and that's the very, very brief and subtle point that I wanted to make today. It's subtle, but it's not too subtle for Shakespeare. Juliet's "What's in a Name" soliloquy in Romeo and Juliet is all about supposition, as I point out in this section of the book. Okay, that's all on supposition. Let's look at distribution. So we've seen that signification, remember signification? That was also in chapter 2. That's a property of terms. It tells us how many meanings a term has, whether it's univocal or equivocal. We've seen that supposition is a property of terms, and it tells us whether the term is referring to itself as a term or to the logical concept it signifies, or maybe to some particular part of that concept's extension. Distribution is also a property of terms, and it tells us whether the term applies to the entire extension of the concept it signifies or only to some part of that extension. And just as with supposition and signification, we can only determine the distribution of a term by looking at the overall proposition. We say that a term is distributed in a proposition when the proposition addresses the entire extension of the concept signified by the term. Otherwise, it's undistributed. So you can think of distributed as being entire and undistributed as being partial, maybe. Distributed, comprehensive, undistributed, selective, or something like that. But the terms that we use in logic are distributed and undistributed. And that's a very important distinction, and we'll use it a lot in the next couple of chapters. Now, it makes sense when we're talking about distribution to consider subject terms separately from predicate terms. So let's look at the subjects. The distribution of subject terms is pretty easy because it follows our distinction between universal and particular propositions. In our matrix, we have separate rows for that. The top row is universal, and the bottom row is particular. So all cats are animals, the A proposition, obviously addresses the entire extension of cats. That's why we use the quantifier all, because we're talking about all cats. Similarly, some dogs are friendly, the I proposition, just as obviously only addresses part of the extension of dogs. That's why we use the quantifier some. And by the same token, some dogs are not friendly, the O proposition, also only addresses part of the extension of dogs. Some dogs are friendly, some dogs are not friendly. Everything on that entire particular row has undistributed subject terms. Now, less obviously, no cats are dogs. The E proposition also addresses the entire extension of cats, because what it tells you is that there's not a single dog anywhere in the cat universe. All of them are non-dogs, right? If no cats are dogs, no dogs are cats. We know that that's reversible. And so we know that the entire extension of cats is addressed. And recall that if we were learning this in some language other than English, then the quantifier here would also be all. We would say all cats are not dogs. We don't say that because it's an ambiguous construction in English. We say instead no cats are dogs. But the sense here is clearly universal. So the rule, subject terms are distributed in universal propositions, A and E. They are undistributed in particular propositions, the I and O propositions. Okay, that's subjects, easy. Now let's look at predicates. The distribution of predicate terms is less intuitive, so we're going to start with the rule first. The rule is predicate terms are undistributed in affirmative propositions, that's A and I, and distributed in negative propositions, that's E and O. So all cats are animals does not address all animals. Even though it does address all cats, it doesn't tell you about any animals that might not be cats. It doesn't even tell you whether there are any animals that might not be, that aren't cats. It doesn't address that at all. So pretty easy to see in the affirmative case why the predicate there, at least, is undistributed. Similarly, some dogs are friendly. Does not address the entire extension of friendly beings, right? Doesn't address the entire extension of dogs, and it certainly doesn't tell you whether there are friendly things that are not dogs. It doesn't even tell you whether there are some dogs that are not friendly. There's just nothing about this that goes to the entire extension of the predicate. So, on the affirmative side, easy to see, undistributed predicates for the A and I propositions. Now, what about on the negative side? Well, no cats are dogs does address the entire extension of dogs as well as the entire extension of cats, because just as it tells us that all the cats are non-dogs, it also tells us that all of the dogs are non-cats. In other words, if you think about this in terms of the Euler's circles for the E proposition, we can see that there's not a single member of either the subject or the predicate class that overlaps with the other. So the E statement tells us the entire extension of the subject and the entire extension of the predicate over on the negative side. All right, that leaves one more, the O proposition. The rule says the predicate of an O proposition is also distributed. But how can that be? Now again, here's the rule. predicate terms are undistributed in affirmative propositions and distributed in negative propositions. So how does "some dogs are not friendly" address the entire extension of friendly beings when it doesn't even address the entire extension of dogs? Well, I have an example that has helped many people. Maybe it will help you. Some groceries are not in the fridge. Now this means that those groceries are nowhere in the fridge. That is, the entire fridge is free of the groceries that are the subject of this sentence. They're nowhere in the fridge. But wait a minute, you might say. Some groceries are not in the fridge doesn't mean that there are no groceries are in the fridge. When we say some groceries are not in the fridge, that does not normally exclude the possibility that there might be some groceries that are in the fridge. There might be some groceries in the fridge. That's the I proposition. But the O proposition tells us only that some groceries are not in the fridge. And here's the key. Those groceries, the subject of the O proposition, those groceries are nowhere in the fridge. So the reason why the predicate of the O is distributed is because the entire extension of the predicate is separated from the part of the subject that the proposition is about. Now, ideally, that will work for you. Ideally, you now understand the distribution of subject and predicate for A, E, I, and O. But maybe you don't. Well, at a minimum, you must know it, or it will cause you academic pain. You can know it by memorizing the rules. Subjects are distributed in the universal row, A and E, and undistributed in the particular row, I and O. Predicates are distributed in the negative column, E and O, and undistributed in the affirmative column, A and I. Those are the rules. It would be great if you understood them and if they made sense to you, and I think probably for most of you, at least 7/8 of the rule makes sense. That O statement for the predicate, a little bit tricky, but ideally the example about ice cream or groceries in the fridge will make some sense to you. There's one other way, and that's that you can remember an enhanced matrix for the 4 basic categorical propositions. And here's the matrix straight out of our book. You can see I've added a superscript for the D or U, distributed or undistributed, into our 4 basic categorical propositions. So instead of just remembering that the A statement is all S is P, you can remember or have in your notes that the A statement is all S with a superscript D is P with a superscript U. And you can do that for each of the other 3 statements. If you do that, you'll see that basically the A statement is DU, the O statement is UD, but the E and I statements are special because they have the same distribution for subject and predicate. They have DD for S and P in the E statement and UU for S and P in the I statement. And that'll have some interesting consequences that we'll learn about in Chapter 6. But for now, that's all that we have for today. I will see you again next time for Section 5.5. Thanks.